As we know, to find the pi, there are shortcut method, general method, and one more method is there, that is nothing but the variation of parameter. So what is this method? Variation of parameter. For second order differential equation, if we consider the second order differential equation, k0 d square y by dx square plus k1 dy by dx plus k2 into y equal to f of x. By using linear differential operator d, we can write this in symbolic form as f of d operating on y equal to f of x, that we know. And the auxiliary equation of this differential equation is what? F of d equal to 0, and by this you can find the roots of this differential equation is m1 and m2, because here order is 2, so there are two roots. So by usual method you find up to CF. So here supposed to be CF is C1 y1 plus C2 y2, and after that by variation of parameter you have to replace this constant C1 C2 by u and v, where here, definitely here y1 and y2 are the functions of x, and therefore what is a particular integral now? That is a u y1 plus v y2, where u and v are the functions of x, and u dash v dash satisfies the equation u dash y1 plus v dash y2 equal to 0, and u dash y1 dash plus v dash y2 dash equal to f of x. What is this f of x? F of x is nothing but this is the right hand side of the differential equation. So very simple way you can find the pi if we have CF. So here this constant C1 and C2 replaced by u and v, where u and v are the functions of x, which satisfies these two equations, and directly you remember the formulas for u and v. U equal to integration of minus y2 f of x upon a dx, and v equal to integration of y1 into f of x upon a dx, where a is nothing but Wronskian. So what is this Wronskian? It is a determinant of y1 y2 and y1 dash y2 dash. So where y1 and y2 we know which are the coefficients of c1 and c2, or you can say here coefficients of u and v. So by this formula you can find u and v, you substitute here and directly you will get particular integral. So if supposed to be third order, if the differential equation in third order, then again you find the CF, that is the C1 y1 plus C2 y2 plus C3 y3 by our usual method, and this C1 C2 C3 means constants replaced by u v w. Definitely this u v w are the functions of x which satisfy these three equations here. Note that this u dash, v dash and w dash satisfies these three equations, and directly we can find u v w, u equal to integration of mod of y2 y3 first row and y2 dash y3 dash second row into f of x upon a dx. If we simplify this determinant, I am getting here integration of y2 y3 dash minus y2 dash y3 into f of x upon a into dx. So note that here you already have, this is your yp. So when we are going to find u, then consider the determinant of y2 y3. When we are going to find v, you consider the determinant of y1 and y3, and to find the w, you consider the determinant of y1 y2, and you will get such type of formulas. So what is v here? V equal to minus, note that here u is positive but v is minus integration of the determinant. So for v you have to skip y2, and that is by determinant of y1 y3 second row y1 dash y3 dash into f of x upon a dx. You solve this determinant, so you will get there this minus sign as it is, integration of y1 y3 dash minus y1 dash y3 into f of x upon a dx. Similarly w equal to integration of determinant of y1 y2 first row and second row y1 dash y2 dash into f of x upon a dx. If we solve this determinant, I will get here integration y1 y2 dash minus y1 dash y2 into f of x upon a into dx. So what is this a? A is nothing but the Wronskian of order 3. Here a equal to determinant of y1 y2 y3 y1 dash y2 dash y3 dash, and third row is y1 double dash y2 double dash y3 double dash, means double derivative here. So note that here Wronskian should not be 0. If it is 0, then this method of variation of parameter is fails, means not applicable. So let's consider some examples on this variation of parameter. Consider one example on variation of parameter. Solve d square plus 4 operating on y equal to tan 2x by variation of parameter. It means that we have to solve this example by variation of parameter method. So how? So solution, given differential equation is d square plus 4 operating on y equal to tan 2x. The solution of this differential equation into two parts. So general solution, or you can say the complete solution. The complete solution of the given differential equation is y equal to yc plus y2. Yc means complementary function and yp means particular integral, cf plus pi. So one by one we have to find. So first part here, cf, step number 1, complementary function. So what is the auxiliary equation of this differential equation? Means up to cf, it is same method. Auxiliary equation is coefficient of this y means this equate to 0. So d square plus 4 equal to 0. This implies that d square equal to minus 4, and this implies that d equal to plus minus under root of minus 4. And we know that d equal to plus minus due to this minus sign I, and under root of 4 it is a 2. So it is a complex number. So roots are complex. So d equal to 0 plus minus 2i. So here real part is 0 and imaginary part is 2. So therefore yc means complementary function. Yc is e raised to real part x means 0x in bracket c1 cos of 2x means imaginary x plus c2 sine of imaginary x. So what is the yc? So I am getting yc equal to c1 cos 2x, because e raised to 0 it is 1 plus here c2 sine 2x. So this is the first part. If we consider this is equation number 1 and we are going to find two parts. So this is our first part, that is the yc, cf. Now how to find pi? So particular integral. So step number 2 now, particular integral. Here we have to use variation of parameter method. So what is this variation of parameter method? That is yp equal to this constant c1 and c2 replaced by u and v, where u and v are the functions of x. So I am getting it is a u cos 2x plus v sin 2x. So how to find u and v? So here u and v are functions of x, and u is given by u equal to integration of minus y2 into f of x upon a into dx. And what about v? Integration of y1 into f of x upon a, where a is Wronskian, means it is the determinant of y1 y2, y1 dash y2 dash. So what is y1 y2? So note that here it is nothing but uy1 plus vy2, and therefore if we compare, so what is the y1? So definitely here y1 equal to cos 2x and y2 equal to sin 2x. And what about this f of x? So note that in the given differential equation, this is nothing but f of d operating on y equal to f of x, means this side is nothing but f of x. So therefore here I am getting f of x equal to tan 2x. So this is equation number 3. Before to find u and v, we have to find Wronskian a. So what is a? A is a determinant of y1, means it is the cos 2x, y2 means sin 2x, y1 dash means derivative of it is a minus 2 sin 2x, and derivative of sin 2x is a 2 cos 2x. So solve this determinant. So I am getting this into this minus this into this. So that is equal to 2 cos square 2x minus into minus 2 sin square 2x. So 2 common. So I am getting here inside cos square 2x plus sin square 2x, and cos square plus sine square theta, that is nothing but 1. So I am getting simply 2. So what is the Wronskian? A, it is equal to 2. So by using this Wronskian, we can find value of u. So what is the u now? U equal to minus outside y2. So y2 is sine 2x into f of x, it is a tan 2x upon a, it is a 2 into dx. So simplify this one, means evaluate this integration. So I am getting here u equal to minus 1 by 2 sine 2x, and tan we can write sine 2x upon cos 2x dx. So that is equal to minus 1 by 2 integration of sine square 2x upon cos 2x. I can write this sine square is 1 minus cos square, because sine square theta plus cos square theta equal to 1. Therefore, sine square 2x is nothing but 1 minus cos square 2x upon cos 2x. So separate it, and that is nothing but minus 1 by 2 as it is integration of 1 by cos 2x. Directly also you can write minus cos square 2x upon cos 2x into dx, and therefore u equal to minus 1 by 2 integration of 1 by cos, it is nothing but sec of 2x minus cos square by cos. So 1 cos get cancelled, and I am getting cos of 2x only into dx. So by standard integration of sec x and cos x, I am getting u equal to minus 1 by 2. So what is the integration of sec 2x? It is the log of sec x plus tan x, means sec of 2x plus tan 2x upon 2, minus integration of cos 2x is sine of 2x by 2. So this 1 by 2 common, so that is why I am getting minus 1 by 4, and inside I am getting log of sec 2x plus tan 2x minus sine 2x. So this is value of u. So it is equation number 4 now. Now how to find v? V equal to integration of y1 into f of x. So what is y1 and f of x? Y1 is cos 2x, f of x is tan 2x. So cos of 2x into tan 2x upon a is Wronskian, it is the 2 into dx. So that is equal to 1 by 2 integration of cos 2x into tan means sine of 2x upon cos of 2x into dx. So cos get cancelled. So simply sine 2x getting. So 1 by 2 integration of sine 2x. So by standard integration of sine 2x, I am getting minus cos 2x by 2. So this minus 1 by 4 cos 2x, it is a v. So once we have the values of u and v, you substitute these values in equation 3. So u cos 2x plus v sin 2x. So what is the yp now? So I am getting yp equal to u. So what is value of u? Minus 1 by 4 into log of sec 2x plus tan 2x minus sin 2x into cos 2x plus v into y2. So what is v? It is a minus 1 by 4 cos of 2x into sin 2x. So simplify this, definitely some terms will be add or cancel. So yp equal to, I am getting, if we multiply, so minus 1 by 4 cos of 2x into log of sec 2x plus tan 2x minus plus. Note that here it is a bracket and then the curly bracket, and that is why I am getting minus plus 1 by 4 sin 2x into cos 2x, and here minus 1 by 4 cos 2x into sin 2x. So this cancel. So I am getting simply yp equal to minus 1 by 4 cos of 2x into log of sec 2x plus tan 2x. So this is equation number 6. So we have now yc, which is equation number 2, and yp, equation number 6 in equation 1. So I am getting the complete solution. So now the step number 3. So from equations 2, 6 and 1, we get complete solution, that is a y equal to yc, which is nothing but c1 cos 2x plus c2 sin 2x. This yp now minus 1 by 4 cos of 2x into log of sec 2x plus tan 2x. Note that here we want y equal to yc plus yp. So this is your yc and this is your yp. So which is your final or required answer? Now consider one more example on the variation of parameter. Solve d square y by dx square plus y equal to sec x tan x. So in symbolic form, this differential equation we can write as solution. Given differential equation d square plus 1 operating on y equal to sec x into tan x. Note that this is nothing but in f of d operating on y equal to f of x. So general solution, or you can say the complete solution of this given differential equation is y equal to yc plus yp. So what is the yc? It is nothing but a cf, and the yp means it is nothing but a pi. So it is equation number 1. So one by one we have to find. So first part is cf. So step number 1 now, that is the cf. So for cf, auxiliary equation is, so what is auxiliary equation here? F of d equate to 0 and find the values. So d square plus 1 equal to 0 and find the roots of this equation, that is a d square. So this implies that d square equal to minus 1 and this implies d equal to plus minus under root of minus 1. So d equal to plus minus under root of minus sign, that's why I, and under root of 1 it is 1. So same thing I can write as a real part and imaginary part. So definitely here 0 plus minus I means real part 0, imaginary part is 1. So what is a yc? It is a e raised to 0x means a real part x in bracket c1 cos of imaginary x plus c2 sin of imaginary x. So e raised to 0 means it is a 1. The same thing I can write as yc equal to c1 cos x plus c2 sin x. So this is your first part, that is equation number 2. Now the second part, that is a pi. So step number 2 now, it is nothing but a particular integral. Here we have to find particular integral by variation of parameter. So what is that variation of parameter? Means directly we can write yp. So c1 and c2 replaced by u and v, where u and v are the functions of x. So I am getting here u cos x plus v sin x. So how to find u and v? So here u and v are functions of x and u is given by integration minus y2 into f of x upon a dx and v equal to integration y1 into f of x upon a into dx. So what is y1, y2? You just observe here and compare with this one. So uy1 plus vy2. So you will get here y1 and y2. So you consider this is equation number 3, and if we compare, so I am getting y1 equal to cos x and y2 equal to sin x. What about f of x? So you can see in the given differential equation, right hand side is sec x into tan x. So that is nothing but your f of x. Now you find first a. What is this a? So before to that you declare what is a, where a is a Wronskian, means it is a determinant of y1, y2, y1 dash, y2 dash, and it is known as Wronskian. So here I want this y1, y2 and this f of x. So what is the value of a now? So determinant y1 means cos x, y2 means sin x, y1 dash, it is nothing but derivative of cos x is minus sin x, and y2 dash means derivative of sin x, it is nothing but cos x, and that is equal to, so solve this determinant, so this into this minus this into this, So I am getting here cos into cos, it is a cos square x minus, so sin x into minus sin x, so minus sin square x. So simplify it, so I am getting here it is a cos square x plus sin square x, and by standard formula this value is 1. So A equal to 1. So once we have value of this Wronskian means A, you can find U, that is equal to minus outside y2. So y2 is what? Here sin x into f of x upon A. So sin x into sec x tan x upon A, it is a 1 into dx. And that is why I am getting here U equal to minus integration of this sin x, sec x means it is a 1 by cos x, and tan x means what? It is a sin x upon cos x dx. So you can observe it is a minus integration of sin square x upon cos square x means it is a tan square x. So U equal to minus integration of tan square x dx. So now evaluate this integration. So how? Since we know 1 plus tan square x equal to sec square x, and this implies that tan square x equal to sec square x minus 1, and therefore U equal to minus integration of sec square x minus 1 dx. So by standard integration I am getting U equal to this minus tan x minus x. So adjust this minus sign, so I am getting x minus tan x. This is your value of U. So this is equation number 4. Now I want to find V. So what is a V? V equal to integration of y1 into f of x upon A. Y1 means cos x into sec x tan x by A is 1. So I am getting here cos x into sec x tan x by 1 into dx. So if we simplify it, I am getting cos x, sec x is 1 by cos, it cancel with cos. So normally if integrand contains sin or cos, so every part you convert into sin and cos. So usually you will get the formula, because most of the formulas we know in the sin and cos. So this cos and cos get cancelled. So I am getting sin by cos means it is simply tan x. And as we know, the standard integration of tan x is what? It is nothing but log of sec x, and therefore I am getting V equal to log of sec x. So substitute, this is equation number 5. So substitute these values in yp. So what is a yp here? U cos x plus V sin x. So we have value of U and value of V also, and therefore from equation 3, 4 and 5, yp equal to U. So it is a x minus tan x into cos x plus V. It is a log of sec x into sin x. So simplify this. So I am getting yp. So yp equal to x cos x minus sin x, because tan x into cos x. What is the tan? It is a sin x by cos x, and into cos x. So I am getting this cancels. So only simply sin x plus sin x into log of sec x plus sin x into log of sec x. So this is your yp, equation number 6. So now we have both part yc and yp. So complete solution, or you can say the general solution, is step number 3 now. From equations 1, 2 and this 6, the complete solution, or you can say the general solution, that is a y equal to yc plus yp. So what is a yc? So we have this yc equal to c1 cos x plus c2 sin x, and now we have yp also. So yc, it is a c1 cos x plus c2 sin x, and yp is now x cos x minus sin x plus sin x into log of sec x. So which is your required answer or required solution, you can say. Consider one more example on the variation of parameter, that is the solve d square minus 6d plus 9 operating on y equal to e raised to 3x upon x square. So solution, given differential equation is d square minus 6d plus 9 operating on y equal to e raised to 3x upon x square. So the complete or general solution of this given differential equation is y equal to yc plus yp, means here cf plus pi. So this is equation number 1. So we have to find cf and pi. So there are two parts. So step number 1, that is the first part, which is nothing but a cf. So how to find cf? The auxiliary equation is. So what is the auxiliary equation? So you note that. So given differential equation is f of b operating on y equal to f of x. So here auxiliary equation is a coefficient of y equate to 0, and solve this. So d square minus 6d plus 9 equal to 0. So it is a perfect square, that is a d minus 3 whole square equal to 0, and this implies that d minus 3 equal to 0 and a d minus 3 equal to 0. It means that d equal to 3, 3 are the roots of this equation, and therefore yc equal to, so here roots are real and repeated. So that is why yc equal to c1 plus c2x e raised to 3x. So this is the first part. So equation number 2. Now the second part, that is the step number 2, which is nothing but a pi. Note that here we want to find by variation of parameter, and the variation of parameter yp is nothing but constant replaced by u and v. So here same thing yc I can write as c1 e raised to 3x plus c2 into x e raised to 3x. So this c1 c2 replaced by u and v. So that is why yp equal to u into e raised to 3x plus v into x into e raised to 3x. So this yp we have to find. So note that here u and v are the functions of x, and we can find u and v as u equal to integration of minus y2 into f of x upon a into dx, and v equal to integration of y1 into f of x upon a into dx. So what is this y1 and y2? So note that here this yp is nothing but uy1 plus vy. If we compare with this one, so I am getting here y1 and y2. So what is this a? So where a is a Wronskian, and it is a determinant y1 y2 y1 dash y2 dash. So if we compare this thing with this one, so I am getting here y1 and y2 as y1 equal to e raised to 3x and y2 equal to x e raised to 3x. So what about this f of x? It is a right hand side function of x, it is a e raised to 3x upon x square. So first you find always Wronskian, that is a, and it is nothing but y1. y1 is e raised to 3x, y2 it is a x e raised to 3x, y1 dash means the derivative of this y1 is a 3 e raised to 3x, and here the derivative of y2 is nothing but u into v rule. First constant, derivative of second, it is a 3 e raised to 3x plus second constant, derivative of x is 1. So solve this determinant. So this into this minus this into this. So I am getting here e raised to 3x into 3x e raised to 3x plus e raised to 3x minus x e raised to 3x into 3 e raised to 3x. So simplify this. So I am getting a equal to, so 3x e raised to 6x plus e raised to 6x, you multiply this inside, minus 3x e raised to 6x. So this plus minus get cancelled, and I am getting a equal to e raised to 6x. So by using these values I can find u equal to minus integration of y2. So what is value of y2? It is a x e raised to 3x into f of x is e raised to 3x upon x square and whole divided by a is nothing but e raised to 6x. So simplify this and evaluate. So I am getting minus integration of, so e raised to 6x will cancel with e raised to 3x into e raised to 3x, and this 1x will cancel with this one, and I am getting it is simply 1 by x dx. So by standard integration of 1 by x is nothing but log x. So I am getting minus log x. So this is your value, which is u. Now you find value of v, and what is the formula? It is a y1 into f of x. So y1 into f of x is e raised to 3x into f of x is e raised to 3x upon x square, and whole divided by a. It is a e raised to 6x dx. So e raised to 6x will cancel with this e raised to 3x into e raised to 3x, and I am getting simply 1 upon x square. So this integration by the formula x raised to n, since this 1 by x square I can write as x raised to minus 2 dx. So therefore, what is the v? Integration of this is nothing but x raised to minus 1 upon minus 1. And that is why v equal to minus 1 by x, because x inverse is 1 by x. So this is your v. So substitute these values of u and v in yp, means equation number 3. So you will get here yp. So from equations 3, 4 and 5, we will get here yp equal to u. What is value of u? Minus log x into e raised to 3x plus v into, so minus 1 by x into x into e raised to 3x. So you can see here, this is your yp. So here I am just putting the values of u and v. So simplify this. So I am getting yp now. So yp equal to minus e raised to 3x into log x minus, so this x get cancelled, and I am getting only e raised to 3x. So this is your yp, it is equation number 6. So we have yc and yp. If we have both value, you just substitute in equation 1 and you will get the complete solution. So now step number 3, that is a collection of all. So from equation 1, 2 and 6, the complete, or you can say the general solution is y equal to yc plus yp. So what is value of yc? So you have yc equal to c1 plus c2x e raised to 3x. So I am getting here c1 plus c2x into e raised to 3x, and now yp is a minus, you can common out here, minus e raised to 3x. So I am getting minus e raised to 3x common inside log of x plus 1, which is your final answer or required solution.